Hello, it's Rochelle. The purpose of this video is to go over solving inequalities. So in a previous video, we talked about how to rewrite inequalities, or how to graph them and rewrite them in interval notation. Now we're going to look at solving linear inequalities. So linear inequalities look a lot like a regular equation. So on the left here, what you will see is a regular old equation with an equal sign in the middle. These are the same left and right side, but you'll notice that it's an inequality in between. We are going to solve it the exact same way. In this case, we distributed the right-hand side. And then at this point, we subtracted 2x from both sides to get 3x on this side. Did the same thing over here. Then we added 15 to both sides to get the 21 there. And then we simply divided by 3. I should have left a little more room there. And we came up with the answer. So the technique is the exact same as when we solve a linear equation, except there's one rule that is different. And that is if we multiply or divide both sides of an inequality, then the sign flips. So let's just show you what that is, and then I'll show you why that is. So in this case, if we're looking at this equation right here, to get x by itself, we would start by subtracting 1 from both sides. Then we would have negative 4x is greater than or equal to 24. And then we would divide both sides by negative 4. In doing that, we would end up with negative 6 over here, and our sign is going to flip. So let me just ask you this in terms of why. Excuse me. I think we could agree that negative 4 and 24, that in this case, 24 is the bigger value. I'm just using these values because they happen to be values that we're looking at. So this is unrelated. Now, if I just decide to divide both sides by any number, let's say negative 2 instead of negative 4, so I understand it's a different. Now, if I divide these two, I'm going to get positive 2, and over here, I'm going to get negative 12. Now, if I look at this, which number is bigger? Well, the 2 is bigger. Thus, the inequality changed signs. Because when we divide or multiply by a negative, it changes where it is in location to 0. So, that's the only rule we need to remember, and that is, if we divide or multiply by a negative, the sign is going to flip. So let's go ahead and practice it. So if I have this equation, there's a few things I could do first. I think I'm going to add 13 to both sides of the equation. And I'm going to end up, inequality, I'm going to have 7x is less than 12x plus 45. Then I'm going to go ahead and subtract 12x from both sides. And that's going to leave me with negative 5x is less than 45. And if we remember our new rule, the fact that we're dividing by negative 5 here means that this sign is going to flip. And so we're going to have x is bigger than negative 9. Now, I love that I made a number line here, but I didn't even make it far enough out so that we could see the negative 9. Whoopsie. But this says greater than negative 9, which means it's going to go from here to the right. And since it's a greater than symbol, we're going to use this parenthesis. Again, I like to sketch a graph because that helps me with interval notation. That means I know that the smallest number is negative 9. It's going to go to infinity, so that's going to be infinity. So this would be my answer in interval notation. This is an inequality notation. So let's go ahead and do a couple more examples. Here, I'm going to go ahead and start by distributing that 5 through and making it 9y plus 5y plus 15 is less than or equal to 10y minus 2.5. Then I'm going to go ahead and combine the 9y and the 5y into 14y. And now I can start combining like terms by moving things around a little bit. So I want my y's to be on the left because that makes it easiest for me. So I'm going to go ahead and subtract 10y from both sides. That's going to leave me with 4y plus 15 on the left and just negative 2.5 on the right. To make sure my numbers are on the right, I'm going to go ahead and subtract 15 from both sides. And that's going to leave me with 4y is less than or equal to negative 17.5. So we're dealing with decimals here. No problem. We're okay with that. If I divide both sides by 4, I'm probably going to need my calculator. It looks like it's going to be negative 4 point something, right? Because I know 4 times 4 is, that's the wrong calculator. It doesn't have any batteries. Oh, I'm going to grab my calculator. I should know this already. 17.5 divided by 4, that's going to be negative 4.375. You will notice I did not change the sign. Even though this is a negative answer here, I only divided both sides by a positive number. So the sign did not change. And so now, again, I like to just kind of visualize, this would be about here and we're less than or equal to. So we're going to go off to the left. So that tells me that this negative. That tells me that I'm going to start at this negative. Oh, I can't seem to erase that. Make negative 4 right here. This negative 4.375. And it's going off to negative infinity. And then just as a bonus, I wanted to solve this more complex inequality. In case you're ever asked to do this. In this case, we're just going to treat it like we have 3 sides of an equation. So I still want to get my x by itself. So I'm going to subtract 1 from all 3 sides of the equation. So that's going to give me a negative 5. This is going to give me a 1/2 x, and this is going to give me 3. Now, to get rid of that 1/2, I either need to divide by 1/2, but the same thing as dividing by 1/2 is multiplying everything by 2. So that's going to give me, negative 10 is less than x is less than 6. So I know that in interval notation is going to look like this. But if you want to visualize it, you'd probably want to make these each 2, negative 2, negative 4, negative 6, negative 8, negative 10. It's going between here and here. That's what the graph would look like. And that's how we solve linear inequalities.